Hello everyone, my name is Abhishek and welcome back to my channel. In today's video, we will learn how to implement CI/CD for databases in an ideal way. To be honest, I wanted to make this video for a long time now because majority of the companies or software engineers in those companies find implementing CI/CD for databases quite challenging. Often DevOps engineers find it tricky to set up ephemeral database environments in their CI/CD ecosystem. Let me explain with an example. Imagine there is a developer and developer creates a pull request to update schema of the dev database. In an ideal CI/CD environment, the CI/CD pipeline should spin up a copy of the dev database and the pull request should be validated against the copy of the dev database. And once the pull request is merged, this copy of the database should be deleted. This is called as ephemeral database environment, where the life of the database is only during the span of the pull request. However, setting up ephemeral databases is not that easy, although there are several advantages of using this ephemeral environment, such as costing. You can ensure your dev database is never corrupted, and multiple other things which I'm going to cover in the problem statement section and also during the demonstration. And in this tutorial, we will be using Neon. So Neon is a managed Postgres platform. So we will set up a free account with Neon and we will spin up a Postgres database. They support a feature called branching, which I'll show you. And using this feature called branching, we will be spinning up ephemeral database environments. And throughout this entire tutorial, in the demonstration part, we will be using GitHub Actions. So we will use GitHub Actions to invoke API of Neon and create ephemeral database environment. And our pull request will be validated against that database copy. This is going to be super interesting tutorial, and I would highly recommend you to watch it till the end and also try this setup. Let's get started. So as I told you, before we head to the demonstration part, let's focus more on the problem statement. So basically, every company has different database environments, such as a production database environment, which is serving the request from the clients or customers, a pre-production or staging environment, which is basically a copy of the production environment. And the reason for having staging environment is super simple. So imagine client reports issue with the production data, or someone reported a security vulnerability on the production instance. Instead of logging into the production database and running some queries, which can potentially create a bigger issue with your production instance, what companies do is they set up pre-production or staging environments, and analysis is performed on the pre-production environment. However, both of these environments are not used by the developers for their feature development. So developers usually work on feature development, that is, they plan to add new features to the product or to the database. But both of these instances are not used for the feature development because they have to be stable all the time. So that's why DevOps engineers create a database environment called developer database environment for the developers. Now, to be cost efficient, what a lot of DevOps engineers or even database administrators do is they spin up a dev database instance and they ask multiple developers from different teams to use this dev database instance. Of course, dev database instance is also created from pre-production or production, but because you already have two stable environments, developers can play with this environment. However, because multiple developers across different teams are using the same environment, it creates a huge challenge for the DevOps engineers. Let me explain how. So like I told you, multiple development teams work on different feature developments. Imagine there is a development team A, and one of the developer creates a pull request. So this pull request targets a part of the feature that their team is working on. And if they're using GitHub Actions, let's say, so GitHub Actions basically connects to the dev database, and developer A may be trying to update the schema of the database or add or delete some data from the database. Now this pipeline, GitHub Actions workflow, executes on the dev database, and maybe it updates the schema of the database according to the pull request of the user. Now this is a problem because when a developer B from XYZ team creates a pull request, let's say to address a bug fix, and when developer B runs the query, probably a particular table, and the schema of the table is updated by developer A. So now the pull request of developer B fails because the schema of the dev database was already updated by developer A. Now this is a huge problem, and developer B thinks the database is corrupted. Similarly, when developer C from a different team creates a pull request, and this time imagine developer C is working on deleting some unused data, but unfortunately developer C writes a wrong query, and when the pull request is executed against the dev database, it deletes some important information from the database, maybe some useful tables from the database. Now this will not only corrupt the database, but it will also block, or it will create productivity issues for development team A and B because the database is corrupted and mostly it's of no use. So they all will come back to the DevOps team, and they will report an issue, or they create a ticket saying that, hey, database is corrupted. Please go ahead and fix it. Now, DevOps engineer takes a lot of time, maybe 4 hours, 5 hours, and tries to address the database issue. Again, the same thing happens. Probably next day, DevOps engineer gets another ticket saying that database is corrupted. Trust me, it happens in real time where companies go for such setup. Now, after a while, what companies do is they realize this model does not work, and the DevOps engineer choose a cost inefficient approach. Now, this is super important. Although this approach works for the developers, but it's a cost inefficient approach where DevOps engineer creates a separate, let's say RDS instance for development team A, different, let's call it as a DB instance, different DB instance for development team B, and similarly for team C. Now this team is happy, this team is happy, and also other development team is happy. But it's a super cost inefficient solution because now the company has a production instance, pre-production instance, dev instance, and multiple other database instances, one for each development team, which incurs huge costing for the organization. Of course, the pull requests are now run very smoothly. Now the development teams are happy, but the company is not happy because of the cloud cost. So now, how do we address this problem? Whether it is the problem that I mentioned here, or it is issue with the cost efficiency, both of them can be handled if DevOps engineers go for ephemeral database environments. That is, if DevOps engineer create a copy of the database during the pull request and Once the pull request is merged, the copy is deleted. Let me explain the workflow. Now, if we take the same example, developer A using the dev database in the previous example. Now, developer A creates a pull request to update schema of the dev database. What GitHub Actions does is GitHub Actions communicates with the API of Neon where this dev database is located. So like I told you, with Neon, we will be creating a Postgres database, right? So GitHub Actions communicates with the API of Neon and creates a copy of the dev database. Now this pull request, let's say there are multiple stages or multiple jobs in the pull request. All of them are executed against this copy. It can be updation of schema. So it is verified if the pull request is successful, the copy of the database is deleted. Even if the pull request is failed and someone closed the pull request, still the copy of the database is deleted. So overall, you have the dev database that is running, but a copy of the database is created and pull request is validated only against this copy. So nobody is actually messing the dev database for the pull request, right? Because you're not sure if the pull request is valid or if the pull request is complete, incomplete. So you cannot take that risk with the dev database. So the good thing here is that Neon integrates with GitHub Actions, right? So that you don't have to create this manually. Let's say, even if they don't have GitHub Actions, you can still write a Python script or shell script because they do have an API. But Neon makes life simple because it can integrate with GitHub Actions. So in the next step, we will explore this. That is, I have a demo application. I have written a Node.js to-do application. And what we'll try to do is, first, we will create a database in Neon. And I'll push my code. I'll firstly show you what exactly is the application. And I'll push the code to GitHub, right? And I will try to create basically a pull request, and we will ensure that GitHub is communicating with Neon, right? I will be creating database in Neon, Postgres database, and we will see if GitHub can talk to the Neon API. And for the pull request that I created on GitHub, maybe I'll try to update some database schema or something. And we will see in real time if Neon is creating a branch. And if my GitHub actions or GitHub workflow is able to communicate with this branch, and if it is able to run my jobs in the workflow against this branch, and once I close the pull request, if the branch is automatically deleted or not. So overall, this is the ideal CI/CD pipeline that I want to implement. So let's go ahead and create an account with Neon. So it's very simple to create an account with Neon. All that you need to do is use the link in the description, and you will head to the login page where you can use your GitHub account or even your Google account. So it's very simple. You can create a free tier account, and in the free tier account, you can go ahead and create a project. So it supports both AWS and Azure. I'll just select the project name as CI/CD demo. You can also select Postgres version. For now, they only support Postgres, and I will choose the database name as Neon DB. If you're using my CI/CD pipeline, which I'm going to show in the video, please make sure the database name is Neon DB only. However, it doesn't matter if you're going for AWS or Azure, because end of the day, it's a managed Postgres service. That is, you don't have to worry about managing the Postgres server. NeonDB takes care of it. Okay, so region, we can keep this and click on the create button. That's it. We have a database instance that is running, and you also have a connection string here. So see how simple it becomes. Like if you're a developer, you can understand that now you have a connection string, and let's say you're using Node.js, they also provide you the code for the connection. Like how can you connect your application to the database using the .env and a sample app.js file. Anyways, I already have a sample application. So I'll just copy this. Okay. And I'm going to connect it with my application that I have locally. Before pushing to GitHub, I'll just show you how we can do it. However, before going there, I would quickly like to show you the different features that Neon has. So firstly, when I create a project, you can see it already created the branches. So by default, it creates a main branch. This is exactly how we deal with source code. When you create a repository in GitHub, you get the main branch. Exactly same when you create a database instance in Neon, you get a main branch, and from the main branch, you can actually create the child branches. Exactly the GitHub workflow. So you get a main branch in GitHub, and you can create child branches called feature branch, dev branch, right? Similarly, by just clicking a button, I can create a branch, let's say dev/a, and I can choose at what point, specific date and time, from which point of main do I want to create the dev branch. Branch is nothing but a copy of the database. And if I click on create new branch, that's it. I can share this Postgres connection string with another developer and tell them that, hey, I'm working on main branch. Uh, please work on this new branch called dev A, so that I don't disturb the other developers' work. So it is that simple how you create a branch in Neon. Anyways, we don't want to do this manually. Like I don't even want to create these branches manually. I want to automate everything through GitHub Actions. So I'll delete this branch for now. Along with that, they also have an inbuilt SQL editor. So you can basically fire some queries from here itself. You don't need a Postgres client running on your machine. You can just log into Neon platform and you can use the SQL editor. You can restore any branch, right, from history or from another branch. You can also see monitoring. It provides you great metrics, observability of your database, basically. And you can integrate this with GitHub, which is exactly what we are going to do. Once I show you my demo application and once I push my application to GitHub, we will come back to the integrations and we will integrate it with GitHub. Of course, because this is an enterprise product as well, like if you want to upgrade, they have a great free tier, but if you like it and if you want to upgrade, you can go to their auth and uh, first you can upgrade and then you can also set up auth for your organization. In the settings, you can basically work with compute, storage, add collaborators, and other things. Perfect. So now let's go to my terminal and see the demo application that I have. A very simple demo application. And to be honest, I used AI to write this demo application in just a couple of minutes. And this demo application that I have here is a Node.js to-do application. I'll run it on my local and show you. But to run it, I need a database, right? That's why we created this database on the Neon platform. So firstly, I want to connect to this. So I'll click on the connect and copy this. Go back and in the .env, let me quickly update the connection string. So .env is a file that we usually don't push to GitHub. To ensure you don't push that to GitHub, you can basically add it to the .ignore file. Because if you share this connection string with someone else, they can actually connect to your database. Perfect. So now I have the database connected. To just verify, we can create a sample table in it. Right now, if you look at the tables, there is actually nothing, right? It's still loading. So this is the Neon DB and it says 0 tables in the public schema. Perfect. So don't worry if you're new to Node.js. I have a wonderful README file. In the README file, I have clear instructions on what command to run. Uh, Even if by watching this video, you can actually follow. First thing, you need to have npm running. So just check if you already have npm on your machine. If not, just go for npm official docs and install npm. I think we already have it in README file as well. Then to install dependencies, just run npm install. Okay. And then we need to populate the DB, right? We should add the schema to the table and we should add values to the table. So what I'm going to do is I'm going to run npm run migrate up. So basically what it does is in the application that I have this migration folder, right? Within the migration, I basically have this, like if you see here, exports.up. So when I run migration up, so basically it creates a table with this particular schema, right? And when I run migrate down, then it basically drops the table. Okay, npm install migrate up. Oh, sorry, npm run, my bad. npm run migrate up. Okay, so it is running the migrations. And you can see here it says insert into this. So it creates a table and it says migration complete. Let's go back and verify. So we are connected. My application is connected to the Postgres database that we created on the Neon platform, and it created a table called to-dos. And right now there is nothing in the to-dos table. Now let's go ahead and start the application. npm start. Okay, so it says server running on port 3000, localhost colon 3000. Perfect. So I have this application running and let's verify by adding an entry to the table of the database. Learn CI/CD for databases using Neon. Okay, let me add this and see. Okay, it's added here. And if I go to the database and let's see if the entry is added here. Cool. So now I can see that the table to-dos has one entry, learn CI/CD for databases. Let me go create a repo here. Let's call this as CI/CD for databases. And let me also provide a simple description so that you all can find the repo, even if you search it. Public, and I don't want to add any of these files. I can add them later. Cool, the repository is created. So now I just need to run git init if I don't have it already. But in my case, if I do git remote -v, I already have origin setup. So I just need to run git add and I need to commit these files. And run the git push command. Cool. Now I run the git push and I can see GitHub repository is updated. Perfect. Everything looks great. I have the README file as well, whatever is required, right? So it has the instructions. It shows how to install. dependencies for the project and everything. Now, how do we set up the CI/CD pipeline, right? The only last pending part. We have the database, we have the application. How do we write the CI/CD pipeline? It's super, super easy. All that you need to do is go back to Neon console and just go to the project. In my case, I just have one project, CI/CD demo. So go to the integrations. In the integrations, go for GitHub and connect the repository that you are interested in. CI/CD for databases. Of course, when you're doing it for the first time, it will ask you to authorize the Neon app for GitHub. In my case, I already tried it out, so I have this. So the GitHub repo was successfully connected. Okay. So once the connection is done, like now that the GitHub repository is connected, if I go back to my GitHub repository, right, and if I go to the settings, you can see what Neon does is within the secrets and variables of your CI/CD, if you go for actions, it has updated Neon API key because GitHub Actions should connect to Neon. So automatically it updated Neon API key. And if you go to the variables, right? So it has also updated a variable called Neon project ID. So overall, it has already connected your GitHub repository to the Neon. And if you go back to this section, they also provide you a sample CI/CD pipeline. So you can just copy this because most of the times it works as is. Of course, I'm going to make some changes and I will just create the pipeline here. For that, add file. So I'll just click on this, create new file, .github/workspaces and my bad. Within the workspaces, I will create a file called neon demo, let's say. Okay, neon demo.yaml. Or you can put it as ci.yaml or cicd.yaml, whatever you feel like. But what's important is what exactly is this pipeline doing, right? Because you have not written the pipeline. Neon itself updated the API key for you, updated the project ID for you. So let's see what else is it doing for you. So overall, what is the pipeline doing? Create and delete branch for the pull request. Now, when it comes to Neon, branch is basically a database copy. So they have their own style of calling it. They call it branch because basically they are trying to, inherit or mimic the style of Git branching so that developers are already familiar with Git branching style. So it makes life of developers and DevOps engineers very easy. So create, delete pull request, a branch for pull request. That's what it is doing. But on what actions? When is this GitHub workflow event triggered? So it is triggered when someone opens a pull request, reopens a pull request, synchronizes a pull request, and even when someone closes a pull request. So overall, this workflow knows when it has to be invoked. And then there are jobs. It's quite simple to understand if you know GitHub Actions. The first stage, what it does is it just picks up a branch name for you. Okay, the setup stage is basically to get a branch name. And how does it get a branch name? The branch name has to be unique because multiple people might be running PR. That's the whole point of it, right? Like I explained here, you might have multiple developers running the pull request, and each of them should have a different copy of the database, right? Developer A should have a different copy, developer B should have a different copy, C should have a different copy. So if multiple developers are working on this GitHub repository, there should be a different name. So that is what this particular job does. So basically it picks the GitHub build ID and it also picks the branch name. We can see that like how the branch name is generated dynamically by Neon. So this is basically for generating a unique branch name. Now, once the branch name is generated, it tries to create the branch. And for the creation, again, there is a condition when the branch has to be created. When the pull request is synchronized, opened, or reopened. That means if the pull request is closed, the job for create neon branch is not invoked. So that's what they are exactly doing, right? So out of the 4 actions here that triggers the GitHub workflow, only 3 actions are selected when the pull request is opened, reopened, or synchronized. On the other action, it should not be invoking this particular job. Okay, and what exactly it does? You don't have to write any script because Neon already has a GitHub action, which is create branch. And this has the entire code. Now, when you invoke, this can talk to the Neon API with the API key that it's stored in the secrets and variables, and it will create a branch here. Okay, great. And that's where it is reading the branch name, API key, and the project ID. Branch name, it got from this particular job. And API key and project ID, it got from the variables. And once the pull request is closed, see here, the another action that we have, if the GitHub event action is closed, then it just deletes the pull request. In between, you can write the logic that you want, right? What Neon does, it provides you a default GitHub workflow, which can create a branch. And when the pull request is created, deleted, closed, it can automatically delete the branch. In between, depending upon your programming language, what actions you want to perform. Here, what were the actions we were performing? We were performing npm run migrate up and npm run migrate down, right? So npm run migrate up for our application basically creates a table or updates the schema. And when someone run npm run migrate down, so basically it deletes the table. So in our case, what we can basically do is, we can just uncomment these lines. They have an example for uh, Node.js basically. So I'll just uncomment these lines. And in my case, the action is npm run migrate up. Okay, this is what updates the schema for me. And rest all is quite same. I don't have to touch anything else. So I'll just commit the changes. Okay, so now GitHub Actions is in place. To create a pull request, let's create a dummy branch. Let's call this branch as test hyphen db migrate. Okay, and we will create this from the main branch. And what I'm going to do is within these migrations, right, I will just update the schema of the table. Now in the create table, I will just remove this part. Perfect. So I've just removed the created at and commit change. Okay, so now the expectation is that the new branch which gets created, when I run the db migrate, it should not have this particular column in the table. And let's create the pull request. So I created few dummy pull requests, and I think this is pull request number 8 or something. So let's see if Neon will be able to pick this change and create the branch for us, that is the copy of the database, and run migrations against it. Firstly, it is picking up the branch name. Okay, great. So it already identified the branch name and it also started creating a branch in Neon, which is basically like a copy that I said. If we refresh, okay, PR8 test DB migrate. So pull request 8 on the GitHub branch test DB migrate. That's what it is trying to suggest. Okay, cool. Now let's see the migration is also successful. Perfect. So this is also good enough. Now let's go back and see in this particular branch. Okay. So in this branch, let's look at the tables and see if the column got deleted or not. That is the schema of the table is updated or not. So if I go to the tables and look for the to do table, I should actually find that. Perfect. We just have ID and title. And that is in the preview branch or the copy branch, the database that got created for us, right? So now the developer can be confident. Assume this breaks on the copy database. It's totally fine. But if this creates any issues on the dev database, then it will impact other developers that are working on the database. So that is how ephemeral database would help us. Now it's very simple. We can just go back, and if we go to the pull request, select, and now just merge the pull request, the copy would be deleted. Even if you don't want to merge and if you just close the pull request, still the copy will be deleted. How? Another action would be invoked, or the job would be invoked, which we wrote in the GitHub workflow. See, right now it is running the delete neon branch. So it should be done post delete, and it says delete neon branch is successful. If we just go there and refresh, we should just see the main branch in the branches section. Perfect. We just have the main branch. So this way, the main branch or the actual database is not altered, and we were also able to validate the schema by creating a ephemeral copy of it. Also, definitely give it a try. You can go ahead and create a free account with Neon. Link is in the description and also in the pinned comment. So create just a free account with it and try to set up GitHub actions and play with CI/CD for databases. See you all in the next video. Take care. Bye bye.